Differentiation is method of finding the derivative of rate of change of a function. The rate of change of function is defined as dy dx equal to fx equal to y. First, we have the constant rule. When we differentiate a constant, the answer is always 0. This is because constant don't change, and the derivative measure the rate of change, so if c is a constant.
Next is the power rule, one of the most commonly used rule in differentiation. If we have x power of n, we bring the power down and minus one of the exponent. This rule applies to positive, negative, and fractional power. Now the constant multiple rule. If a constant is multiplied with a function, we simply keep the constant and differentiate the function. This makes differentiation easier because we can factor out the constant first.
Next is the sum and difference rule. When the functions are added or subtract, we can differentiate each term separately, so we differentiated each part one by one.
5. We have product rule. Here we have the product rule. We use this when two functions are multiplied together.
Next is the quotient rule, used when one function is divided by another. So we differentiated the top multiplied by the bottom minus the top multiplied by the derivative of the bottom all over the bottom squared. Finally, we have the chain rule, used for composite function. That means a function inside another function. In simple words, differentiate the outside function first, then multiply by the derivative of the inside function. Question A, find the dy dx for the following function. So, the question tell us to find the differentiation of these terms. We determine the es times 3 as a u and the sin bracket s times 2 plus 3 as a v. So we need to find the u prime. So we got the u prime is the 3s times 2 exponent s times 3. So next we need to find the v prime. Firstly, we need to got the differentiation of sin, second differentiation of s times 2, and third one is the differentiation of 3. So as a result, we got the cos bracket s times 2 plus 3 bracket 2s and bracket 0. We just bring 2s in front of the main terms. So this is the result for the v prime. Let's move step 2. As usually, the product rule is a u v prime plus v u prime. So we just substitute the product rule. So the u multiply with the v prime and we get plus the v multiply the u prime. So we just multiply the s times 3 for each term in the bracket, and we move the 3s times 2 exponent s times 3 in front of the main terms. Step 3, this is the result from the we multiply. S times 2 plus 3. Yes. So we need to factor the s exponent s times 3. This process to simplify the differentiation of terms, and we got the answer, and the differentiation is completed. Right. The question B, we need to differentiate the s times 2 times 2s divide 1 plus s times 3. We determine u always denominator and v is always denominator, and we need to find the u prime. So u prime, we need to use a product rules because there are two terms that are multiplied together. And then next we need to find the v prime. As always, we find the differentiation of 1, differentiation of s, and differentiation of power of 3. And the other result is for the v prime is the 3s times 2. So the product rules is the u times b prime plus b times u prime. So we just dedicate the u, b prime plus b and u prime. So we multiply the 2 with the s times 2 and we bring the 2s in front of the main terms. So we got the u prime. So next we use the QR quotient rules. So we just substitute the v u prime minus u v prime. So I write the left terms with a blue color, with a light blue color. So I multiply all the first bracket with each terms in the second bracket. So we got this for the answer. And the left side I write with a dark color of blue. I bring the 3s times 2 in front of and multiply with the negative s times 2. So I write a completely one. The last two of the terms we can simplify, and we got the negative x4 plus time bracket 2x for the last two of terms. And I just write the completely differentiation answer for our differentiation. And we just need to divide with a bracket 1 plus s power of 3 bracket power of 2. So that's all.
For question 3, I will explain how to find the y dx using implicit differentiation. Given x squared exponent 2x plus y equal to sine power of 2 for x plus ln y power of 3. Step 1. Since y is a function of x, we differentiate both sides with respect to x. Next, we use u prime v plus v prime u. Step 2. Differentiate the right hand side using change rule. Sine power of 2 bracket for x. Step 3. We differentiate the ln y power of 3. Step 4. We combine both sides. Then we got the answer. dy dx equal to 4 sin 8x minus e 2x plus y 2x plus 2x square divided by x square e 2x plus y minus 3 divided by y. That's all.
This question asks us to estimate the value using linear approximation. First, I define the function. Let f of x equals x to the power of 1 over 3 minus x to the power of negative 1 over 6. Next, I choose equal 64 because 64 is the power of 2, which makes the root easy to evaluate. Then, I evaluate the function of x equals 64. So the cube root of 64 is 4 and the sixth root of 64 is 2. So f of 64 equals 4 minus 1 over 2, which is 3.5. After that, I differentiate the function. The derivative is f prime of x equals 1 over 3x to the power of negative 2 over 3 plus 1 over 6x to the power of negative 7 over 6. Next, I substitute x equals 64 into the derivative. This gives f prime of 64 equals 17 over 768, which is approximately 0.022135.
Now, I apply the linear approximation formula, which is f of x is approximately equal to f of a plus f prime of a times x minus x. X equals 64.02, a equals 64, so x minus a equals 0.02. Substituting the values, f of 64.02 is approximately equal to 3.5 plus 0.022, 135 times 0.02. This gives f of 64.02 approximately equal to 3.500427. Finally, rounding to 4 decimal places, the answer 3.5004. That is the required estimate using linear approximation.